Okay, let's implement Nesterov optimizer together. We first need to initialize our momentum, V here, and this is the same as just basic momentum, so I'll just copy this code block here. And the next thing is for each parameters, we need to perform update. And to do so, we need to first update the momentum. And this is raw multiplied to previous V minus learning rate times gradient at time step T. And to implement this part, we first multiply the momentum to our V. And the first line corresponds to this part. And the second part is minus self-learning rate times grad T. And now our V has become BT plus 1. And the next part is somewhat tricky. We need to calculate T plus 1, XT plus 1, and that was, according to this equation, looks like this. XT plus 1 corresponds to X tilde XT plus VT plus 1 plus rho times VT plus 1 minus VT. But the issue here is we now don't have VT because we've already updated VT plus 1. So we have VT plus 1, however, we don't have VT. How can you resolve that? And I'm going to show you how we can do that. This might be tricky to implement when you first implement this part. So I'll write down the original equation. Rho times VT plus 1 minus VT. And you can actually get rho times VT from here. And by changing from here, you can get R times VT, and you put this equation here. And that becomes, the first part is the same. And the second part is R times VT plus 1 minus R times VT. And we're going to, this part remains the same. And for this R times VT, here we have R times VT. So we are substituting R times VT with VT plus 1 plus learning rate times G X plus XT. And that becomes minus, because we have minus sign here, VT plus 1 minus learning rate times gradient at XT. And this one cancels out this one. Okay. So we can remove this part and this part. And this is how we are going to update our X using R times VT plus 1 minus learning rate times GT. And you now might have realized that because we are receiving parameters and gradients, we don't have access to gradient T plus VT. We can't do this because we just want to receive, we just want to separate the implementation of optimizers from that of gradients or networks. To achieve that goal, we are expressing everything with the given variables, grads and parameters. And let's implement this part. After you figure this out, implementation becomes very straightforward. So what you need to do is you just self.momentum times self.v key. This corresponds to this part. And after that, you need to subtract self LR times grads key. And this is basic Nesterov optimizer. And you might see this as well. This one is called accelerated Nesterov optimizer. So this is just for reference. So you multiply momentum one more time here. And here, you multiply 1 plus self-momentum to this term. And this will even more accelerate this momentum. All right, let's move on. And the next optimizer we're going to implement is ADA grid. First things first, we need to implement the initializer. This one just receives the learning rate. And we need to keep track of the accumulated gradients. And we will do that with H. And all the optimizers have this common method, parameters and grids. And we need to initialize H for the first step. And we're going to implement this with a dictionary. So this is very similar to that of momentum. Like this. And for each key in params keys, what we are doing is update or accumulate the gradients. And before we do that, we square it. And after that, what we do is just do, this is simple stochastic gradient descent. And here, we are adding a scaling factor. And because we're dividing, we need to add a small number to avoid guarantee numerical stability. So this is ADA grid. Okay. And the next optimizer we're going to implement is RMS prop. This one receives decay factor in addition to learning rate. And we also need to initialize HS none. And for this update method, it's going to be our next PPP exercise. Think about it on your own. And I'll give you another problem that is going to be Aram. I'll give you the initializer. So we need to receive learning rate, beta 1, beta 2, And we need to keep track of the number of iteration because we need to correct the bias. And we'll keep track of momentum and the size of gradient. We need to accumulate the gradient. This is another PPP exercise because these two problems are correlated because Adam combines RMS prop and momentum. Think about it on your own and see you in the next video.